For nearly all of human history, survival meant navigating a dense, three-dimensional wilderness. Every step required your body to read the terrain, duck under branches, and react instantly to an unpredictable environment. Our brains evolved to process this intense stream of physical data. Picking up a stone tool meant evaluating its weight, testing its rough edge, and sensing its center of gravity. We literally think with our bodies. Today, we spend our lives staring at unyielding, flat planes of glass. These digital screens offer zero physical resistance and absolutely no tactile feedback. Our brains are highly optimized to seek and process kinesthetic data. When we stare at a non-responsive surface, that stream of data is cut off, yet the brain continues to seek feedback that never arrives. This unresolved physical search creates the chronic, low-level stress and exhaustion we identify as digital fatigue. The solution is kinesthetic design. By programming our flat interfaces to mimic the textures, physics, and spatial layouts of the natural world, we can finally satisfy our evolutionary wiring. It starts with touch. Human skin is a high-fidelity data-gathering tool, constantly sending the brain information about the damp give of moss or the sharp edge of a stone. This tactile database makes the world feel real. Physical architecture uses this to its advantage. When you run your hand over a heavy wooden table or look at the organic grain of a paneled ceiling, those material choices send immediate signals of warmth and life to your body. Translating that sensation to a sterile smartphone screen is difficult. A perfectly smooth, featureless digital void gives our spatial awareness absolutely nothing to hold on to. We can solve this mechanically through haptic technology. When your phone emits a micro vibration as you press a digital button, it provides physical confirmation of your action. It builds trust by acting like a real-world machine. We can also trick the brain visually. Adding a subtle, paper-like grain and slight drop shadows to an otherwise flat background provides a visual haptic cue. Your eyes see the texture and your body feels it. Layering these digital haptics and visual textures converts a completely flat, unresponsive screen into a tangible surface that the human body recognizes and accepts. In nature, nothing moves instantly. A falling leaf rides air currents, accelerating and decelerating organically based strictly on gravity, momentum, and friction. When digital menus simply blink into existence in a fraction of a second, they violate the laws of physics. It jolts our nervous system because our brains expect organic, continuous motion. Developers fix this with a mathematical timing curve. This compares rigid, linear motion on the left with an ease-in, ease-out velocity graph on the right. Applied to a sliding interface, the menu starts slowly, accelerates, and gently decelerates, perfectly mimicking a real object's drag. This biomimicry extends to our everyday gestures. When you swipe down on your phone to refresh a feed, you physically pull against digital resistance, feeling the tension build before it snaps back into place. By mirroring natural physics, developers allow users to navigate digital environments using innate muscle memory instead of conscious thought. Beyond touch and motion, our brains maintain a constant intuitive map of where our bodies are in physical space. This is a sixth sense called proprioception. Evolution shaped this spatial awareness around two distinct needs: prospect, meaning an open, bright view of your surroundings, and refuge, the security of a small, enclosed area. Great physical architecture balances both. Deep overhangs provide necessary refuge, while a wide view of the desert landscape offers the prospect our brains crave. Engineering that psychological sense of depth on a completely flat screen requires a direct hack to human biology. We achieve this using parallax scrolling. This exploded 3D view of a web page shows distinct visual layers. As the layers compress and scroll, staggered speeds target human proprioception. It mimics walking. Foreground elements fly past quickly, while distant backgrounds barely move. Mastering parallax and proprioception changes the internal logic of the interface. Users can explore a digital environment with the same spatial awareness they use to navigate a physical room. Translating haptics, momentum, and spatial depth successfully bridges the gap between our flat screens and our physical brains. And this bridge is about to become mandatory. As we transition away from glass screens into fully immersive spatial computing, we are entirely enclosing our vision and cutting off the physical world. In a screenless, three-dimensional digital space, you turn your head to look and reach out your hand to grab. The rules of kinesthetic design dictate the entire foundation of how we interact with these computers. By grounding our digital systems in these tactile lessons, we ensure that as technology becomes more abstract, the user experience remains centered on the physical requirements of the body.